In this video, we're going to see the operation of induction motor. Before going to the operation of induction motor, let us see how, let us see the principle of Lenz's law. Suppose when we have a magnet and there exists a winding here. So when this magnet is moved towards this, there exists a rate of change of flux. When this rate of change of flux is linking with this coil, it actually develops a potential difference or induced EMF. So this potential difference doesn't have any influence on this magnet unless it is a closed circuit. See here, now there exists a potential difference and this magnet is moving. So there is no, though it has developed some potential difference, there is no opposition. But if you see that now, if this is being closed with some load or even it can be a short circuited, so as there exists a potential difference, it actually drives some current in this direction. So due to this change in flux, it actually develops an induced EMF, and this induced EMF, this potential difference, when driven through some load, it will have some current through it. So what happens, according to Lenz's law, there exists an induced EMF of L di by dt, which is opposing this moment. So this magnet will experience some backward force from this current. Assume that, say, here you can see the moment of the current. So when there exists a moment of this, like the folding fingers are like this and your thumb will be like this. See, you have to hold your fingers along the direction of current. So the thumb indicates your direction of flux of the cause. Now this cause has to be opposed by this Lenz's law. It is, and that means as magnet is moving this direction, it is actually developing a current in this direction, and because of this current it has to oppose this moment. So this magnet will experience some backward force. Let us experience the same thing through some video. If you see here, he is showing a circular aluminum coil and he has left a magnet inside it. But if you see that the magnet is going very slow, it's not fast enough. It is being reduced. See here, now he has increased that and even its flow is further increased. Let us see the same operation now. As a magnet, let us assume that this is a magnet and magnet is moving in this direction. Now what happens as magnet is moving in this direction? So it actually develops a potential difference like this. That means from here to here, there will be a potential difference. And this is a closed circuit. It actually drives some circulating current inside it. So when there exists a circulating current, this circulating current has to oppose this magnet. This is an aluminum coil and this is a magnet. So it has to oppose this magnet. What happens? It actually opposes magnet and the force developed, the force is developed actually. And this is opposing this. But what happens when it opposes this? The movement will be reduced. That means it actually gets slowed. When it gets slowed, the d phi by dt will get reduced. When d phi by dt reduced, again the di by dt will get reduced. As di by dt is again reduced, there will be less opposition to this magnet and it again starts falling. When it falls, again d phi by dt will increase. So as d phi by dt is increasing, again there exists more di by dt. So when there exists more di by dt, it again opposes this. So this is why when di by dt is again increasing, there will be the motion of the ball will get slower. This is how you can see that how Lenz's law work. Now let us see the same operation in an induction motor. See, we have three coils. Let us assume A dash. That means A is wound here and it is circulated like this and A dash is coming out. see how the A dash are being connected to a voltage source B dash, C dash. If you see A, B, C, they are physically displaced by 120 degrees. If A is here, in physical 360 degrees, if this is reference 0, it is angle minus 120. And this is again minus 120 to this one, or minus 240 with respect to this. And see that the coil is entering here and it is leaving here. If you see that when coil is entering here, now I am folding my fingers like this. Coil is entering and it is leaving, so the folding fingers come out. So it is folded like this, and if you see the direction of flux, it is like this. Okay, for this one, it will have the direction of flux in this direction, but the voltage appeared across A dash VA. Let us assume that VAB. This is a sinusoidal quantity. Let us say sine omega t. So what happens at one instant, maximum flux will be developed, and at the same time minimum flux will be developed. After some time, what happens, the direction of current will get reversed. As the sinusoidal quantity, as the voltage appeared will be reversed, the direction of current will get reversed. Now direction will be like this. So for this one, now the folding fingers will become like this. Now you can see the nails. Sorry for the, it's okay, I can again understand the diagrams. So for this one, the direction of flux will be like this. Now when there exists a d phi by dt in this direction, it actually develops a torque in this direction, and when there exists a d phi by dt in this direction, it actually develops a torque in this direction. But as the frequency is very high, the rotor cannot move in either direction, because it will move to some extent and it will move to some extent. So the net torque will become 0 if there exists only one phase. So when actually, if there exist 3 phases, that means each of the quantities will have omega t minus 120, omega t minus 240. So each of the quantities will have a rotating magnetic field. At one instant, this will have a maximum. At one instant, this will have maximum. At one instant, this will have maximum. See, all these 3 are actually developing flux in this area only. So if ABC sequence in this area, if all the flux will get added, and it will resultant into some flux like this. The resultant flux will be 3 by 2 Fm. Fm is the maximum flux developed because of each phase into cos omega s into t into cos theta, where theta is a physical displacement. That means if I take this as reference point, this point will be 60 degrees with respect to this point, and this point will be 120 degrees with respect to this point. I mean physically, this will be 180, 240, and so on. So it will have a flux like this. If you take at one instant, if you start varying this theta, it will have a maximum flux. Let us assume that it will have maximum flux like this, and it will have a minimum flux here. If you take, because cos 90 will become 0, it will have minimum here, and again it will have a negative maximum at this point. That means if it is Fm here, it will be minus Fm. From this we can say that, so it is Fm 0 Fm. So what we can say, this Fm, after some time this will be moved actually. After some time, if you see, this Fm will move to another position. If you take the with respect to time, so actually I kept initially time constant, and I have seen physically about the magnitude of Fm 0 minus Fm like this. Now if I vary with respect to time, the Fm will be here for some time, and after some time it will move here, and it keeps on moving. So from this we can say that there will be a rotating magnetic field that is developed across this. Okay, that means a rate of change of flux is developed here. When this rate of change of flux is linking with this coil, which is a closed circuit one, which is shorted, when it is shorted, it actually develops. That means rate of change of flux linkage is happening here. Flux linkage is happening in this coil, and this is a closed circuit. It actually develops some current Di. So what happens when initially the force is very high, I mean the flux d-phi/dt is very high. So what happens, it started developing di/dt. A large current will be developed, and again this large current has to oppose this flux. Okay, so what happens when this opposes this flux, and this rotor is placed on a free bearing, placed on a bearings. So what happens, as this is rotating, this flux is rotating, this rotor is opposing this, and because of that, as you know, there is a fixed object and there is a moving object. Assume that this is placed on some wheels. So when this moving object is applying some force, what happens, this object will also move. Because of this, as there exists a rotating field and the rotor is placed on a free wheel, this will experience a resultant torque in this direction. So it actually starts moving like this. So what happens, in the same way, as you can see, as there exists a force on this ball, it keeps on moving and there exists a circulating current on this. Similarly, when there exists a rotating magnetic field through the supply, it actually develops a current and finally it will reach to the maximum speed that it can. I hope you can understand the operation of an induction motor. Thank you.